We were going to do approval tests with the approval tests library written by Llewellyn Falco, and we had it working. Like every good developer, it worked on my machine, but no one else's. And we were fighting that up until about 2 minutes ago. Luckily, we have a professional here named Nathan Carver, and he will show us exactly how to do approval test without the library. Totally think you should check out the library. We'll drop some links into the Slack channel, the Twitch and Twitter. But yeah, I want to throw it over to Matt and Nate. And yeah, Matt, start off with, what'd you learn about approval test just before it quit working on my machine?
Sure. So in the 5 minutes that I used it, it seems like a pretty cool tool. Basically, you set your expected values, you run the test, and then you get 2 files created, one with what the output was, and then one file with what your expected input should be. And then basically you paste what your expected output should be, and it's basically like a diff checker. So you're comparing the 2 files and making sure that they're equal. That's kind of my 5 minutes with it. It seems like there's a lot more you can do with it, though. Definitely check it out.
Exactly. And I'm going to throw this over to Nate, and then I'm going to turn off my camera. But Nate, you can show us how to do the exact same behavior with characterization tests, can't you?
We can show you characterization testing. That is right. And we will achieve the outcome we want. So, all right. Thank you, Joel. So let's get started. So what we're going to do tonight is Matt and I are going to be going through a piece of code, just a small piece of code. It's actually the tennis game. You've probably seen the kata in several places. And the idea is this is some production code that doesn't have any existing tests. And someday in the future, our goal is to make some changes and some improvements, some refactoring, maybe fix some bugs. But we have to put tests around it. So the goal of our characterization testing is we're going to write tests that capture the existing behavior of this class. And we just want the behavior as it stands. We do have a scoring documentation here, as every good legacy code has documentation somewhere explaining how it works. And so we're going to use that as our guide. But since our goal is to capture the behavior as it is, bugs and all, it's only a guide. And so we're going to have to explore a little bit with our testing. And at the end of this, we will have tests that will start to create test safety. All right. So you ready, Matt?
Sounds good. I'm ready.
So Matt's going to be the driver tonight. We probably won't ping pong. He's going to stick with the driving, but he and I are going to talk through this. And we haven't really, Matt hasn't seen the code. I've seen a little bit of it. And so we're going to go in and start exploring. Let's do it. All right. So what do we have for our scoring, our documentation there? What does it say?
Oh,
I'm not a tennis enthusiast, so I apologize to tennis enthusiasts if I butcher the rules here.
I have a basic understanding, but I wouldn't call myself an expert.
Okay. All right, so the scoring says we need 4 points to win the game of tennis. The points are known as 15, which is 1 point, 30, which is 2, 40, which is 3 points, and the fourth would result in winning a point. And at the end of that game, the score went to 40-40. This would be known as a deuce. When the game reaches deuce, the player must then win by 2 clear points. Okay, so that's our rules. So we got that. So let's go look at the tennis game, see what we've got in here. All right, so what do we have? We have a class, right? We've got some constructors there. We've got a public method of score. And then we have a point method that takes a player.
So score is a property, right?
Yes, property. It looks like it's a read-only property, right? From with an internal set there. So what do we have as we scroll down? So we have a long method here with if blocks. Got a lot of text in there.
A lot of conditionals, yeah, a lot of text. Nested conditionals.
That looks fun. Okay.
Pretty straightforward though, 78 lines.
Yeah. So we're fortunate. This could have been a lot bigger, right?
Right.
Okay. So let's start writing. Let's start playing in a test here.
Okay.
So what can we interact with first? Looks like we're gonna have to create this guy. So let's do that. Let's create a tennis game.
Okay.
Looks like he wants 2 strings, a player 1 and a player 2. I'm assuming that's player name, perhaps?
Possible. Yeah, it sounds like it.
Okay, let's do that.
Just call them player 1 and player 2, okay?
Yeah, let's go over there. Let's do Nathan and Matt.
Oh, that's true. Let's do that. Probably player 2.
Awesome. Okay, let's explore a bit. So what do we have? So if we do, what happens if we call score? Let's try that. It's a simple property. What's it going to give us at the beginning?
Want to store that somewhere?
Let's do an assert on
Or
it.
we just assert?
Yeah, let's do an assert on it. Just assert equal. It's returning a string.
Yeah,
Yeah, so let's do
yes.
an R equal on it. Let's just give it an empty string. We'll run it and see what the test says. Should be there.
Yep. Okay. All right. Let's run it.
So while that test runs, some people in the Twitch chat are they're going to play the role of middle management, and they want to know if you can hurry up and get this done. They want you to make some changes to the code without breaking it.
Ouch. Changes to the code. Well, that's a good question, Joel. But I'm not ready to make changes to this code because I don't feel safe doing it. I don't want to do something. Because that's a pretty long method. And I'm not sure, like the documentation tells me what a tennis game should be, but I don't know if this code actually does that, right?
Hurry up and type more.
Right.
I don't hear
documentation,
typing.
I think, is 100 years old. So
I don't hear typing. We are not making money. All right, I got to go back to my important manager things. I'll see. I'll be back in a minute. You better have it done.
All right.
Well, as soon as we pass
we'll
this
be in
test,
on
we can
Saturday
ship
to do that.
Drop questions in Slack. I have no problem interrupting these pair. If we derail them with questions about characterization tests, let's do it.
And it'll fill some time. All right. So what was the test result?
So let's see.
Failed, and it said love all. Okay. So if we create a new game and we call the score method, it's going to return love all. I don't remember that being in the documentation, but that's okay.
Yeah, I don't
We'll
see
put that
anywhere.
Yeah, we'll put that in our so let's make that assert equal. Let's instead of string.empty, we'll make it love all.
Okay, it goes expected, right? So we'll do, and I'll do that. Okay.
And then let's come up with a really good. No, let's make sure.
Jumping ahead.
Good call.
Okay.
All right, we're green. So we've captured some behavior. So what is this behavior? What does love all? Does that mean tie?
So I think that means, so love is 0, 0. Love is 0 points. I don't see that in the documentation anywhere.
Okay.
So love all would mean 0, 0.
Okay, so this is a new game. So score 0, 0. Right. Let's call that. Let's name our test like that. So
okay.
New game starts at 0, 0.
Hey guys, my project manager, Q Coding, he just notified me that apparently the documentation's not correct.
Oh my gosh, it is 100 years old.
Could you guys hurry up and get this done? Okay, I promised this yesterday. I have a bonus on my PowerPoint. I have to deliver this. Else I'm not getting my hair plugs, okay?
Oh my gosh.
Hurry up. I'll be back.
Okay, go get a tan.
We passed the test, so it's good to go. I think we could ship it.
Yeah, let's ship it. Let's go to the next test.
All right. So now Should we look for like somehow to score somewhere?
Yeah, so we got another method to interact with. So
Yeah.
let's try interacting with it and see what happens.
So this point method.
So yeah, it looks like it wants, I guess we're gonna have to give it a player name,
Okay.
right? I mean, it doesn't really
Right.
tell us. Yeah, so let's give it one of our player names.
All right. New method?
Yeah, let's do a new test method. We'll call it just test for now until we figure out what it does.
And then a new game?
Yeah, let's do a new game.
And then we'll do.
All right, so we're gonna call point. So game.point, right?
And we'll give it Nathan.
Yeah, I think it's unlikely I would score, but let's try it.
And should we do an assert here?
It doesn't return anything. So yeah, I guess let's do another assert on score and see what it gives us.
All right. Oh, I debugged it, but
we'll get there. A little longer on debug.
Yeah. Okay.
So 15 comma love.
Love.
Yeah. So love is 0 then.
Love is 0,
sure, yeah,
and then you have 1 point, which is 15. So I'm just okay, and then player 1 score is always first, I guess.
Yes.
Because you're player 1.
Yeah, because in the constructor, right? That was player 1 was the first.
Right.
Okay. Excellent. All right, so I guess we need to capture that string and make that our expected equal.
All right.
Okay.
So in characterization test, are you just automatically assuming basically that the output is, because we're just kind of going by like, we just put love all here, 15 love, we're just kind of going with the flow like that this is correct?
Yeah, so I'm assuming, I have to make some assumptions here. The documentation didn't say anything about using love. And I think what this thing is doing is we're just returning us just a score, just maybe how you would call it out in the game. Don't they call out the score in the game? Not sure.
Right.
So yeah, there's a lot of unknowns here, I think, coming in. So what we really want to do is just capture, we want to capture what the code is doing. And like you said, just go with the flow. We'll put some inputs in and we'll capture the outputs and keep them in the task. So I think we'll want to describe this test. So what is this? Player one
scores, I guess, right?
Yeah, player 1 scores.
Player 1 scores first point.
Yeah, that's good. I like that.
So when we get to a natural pause, Nathan, I think people heard the definition the first time. As they see the code written of what a characterization test is, could you explain it again? Like why it's called characterization, even the name, and what the intent is? When you get to a break, I'm being nice now. I'm not being the middle manager. But hurry up and get it done.
Go get your plugs. Yeah, thanks for the interruption, Joel. We appreciate it. Just that flow is gone. No, if someone did ask that, it's a good question, right? So, and that's what Matt was asking is we're just trying to capture what this code does, characterize it. What are the characteristics of this code? And we don't care if it's, well, we do kind of care, but we're not trying to fix it. We're not trying to determine, we're not trying to refactor it at this point. We just want to make sure that we wrap tests around it. So we capture the existing behavior as it is. Whether the code is right or wrong, whether it's accurate in how tennis is actually scored, it doesn't matter, but with what we're doing right now. So
if
all
we
right.
see something like 2 + 2 = 5 or something in the code, which is obviously wrong, we just kind of go
Yeah,
with
we
it and
keep it.
say, and
Yep.
now 2 + 2 = 5 in this code. Okay.
Yeah. So the goal is just to capture that behavior as it is, bugs and all. So
Okay.
yeah. So if it was 2 + 2 = 5, then we're going to live with that until we can create enough safety to refactor it.
Okay.
So yeah, let's. So I think we could refactor our tests a little bit to help define some of our. We could probably.
Agree.
What do you think?
These player
Yeah,
names can probably be pulled out.
Yeah, so let's like make a player 1 and player 2. We could just use constants if we wanted to.
Okay. Kind of like that.
Yeah, let's do that.
Oh, I guess I should. Let's do this.
Yeah, that's fine.
There's not too much to replace. Okay.
Okay.
And
yeah, let's give it on line 22. We'll pass in the constant there too.
Oh, yep. All right. Go ahead and run it. Cool.
Still green. All right, so we didn't break it. All right, let's do another test, and then we'll see some more refactoring, I think, in our test. Okay, so what can we do next?
You want to do so we have player 1 scores first point. You want to do player 2 scores first point?
We could, yeah, we could. So player 1, how about if we try to walk through that first if block?
Okay.
Yeah, so I'm assuming we have to pass in player 1 again. And then.
Right. So we're doing this test.
Yeah, so we could do, we could create a new test that scores a second point, or we could have one test that says, we could change this up. Why don't we do, we'll score a point, assert the score, and then do another point and assert the score right after that and see how that changes.
So we'll do those. And we're asserting twice in this?
Yeah, you could assert after each point to see how it's changing.
So I guess when I write tests, which is occasionally, I rarely do. I try to stay away from writing multiple asserts. What are kind of like your thoughts around that?
Yeah, I tend to avoid them. I avoid multiple asserts if they aren't dealing with the same behavior. Right. So and that's kind of what approval tests are doing is if I have an object with 100 properties and some behavior may change 20 of those, right? I'm going to need 20 asserts, but really what I'm looking at is an existing state of an object. Even though I need 20 asserts to do it, I still have to check all the aspects of that state. And so that's kind of what the approval test is doing when it captures like a JSON, right, object in a file, and then as a snapshot. So it's looking at the data as a whole, not individual pieces of data.
Right.
So in this case, and we may decide this doesn't make sense, but for right now, we can kind of explore. We can explore a little bit with this test, and then decide if it's a duplicate, maybe we get rid of it, or maybe we find it valuable.
Right.
So yeah, we can just play around with it and see where it takes us.
Okay. So I think I accidentally kind of jumped ahead here by changing this to third. I guess.
Oh yeah,
if we're doing this in order. Is that okay to do? We don't have to fail it on the first try. We just kind of are.
Oh yeah, I think we're expecting this to happen. So let's see. right? We do
Right.
see some of that in the code, so I think that's okay.
Okay.
All right,
Yep,
so that
looks like it
that
worked.
did as we expected. And this is, this is pretty common. If you're looking at the code and you see some if statements we want to characterize, we can be intentional, right, in our tests.
Okay.
Especially since, this is pretty easy to read with all the text in there, but if they were random variables that didn't have a meaningful name, then we might have to experiment a little more.
Right.
Okay, so what is this doing? This is player one keeps scoring. So what if we just take player one? What if we just keep scoring until like player one sweeps the game? Why don't we try that?
Okay.
Yeah. So you can actually put that in that test, maybe. Let's not.
Oh, just keep the same test?
Yeah, let's see if maybe this will be a player one sweeps the game test.
Okay, so we'll do. All right. So first came 15, then came 30.
And then it looks like
40,
40.
I think, if I'm remembering correctly. Yep. And then
it should be win,
we'll score
right?
again. And then, well, 40 would be the game point, or match point, or whatever, game point, I guess. And then now this would be the winning point right here.
Okay.
Is that right?
Yeah, I think so. Yep. So 3 points is 40. Yep. So that's 3 points.
Right.
And then the fourth is the winning point. Okay.
And then the fourth is the winning point. Yeah. So I don't know what.
Yeah, I didn't see what it would return, but we can just run it and see what it gives.
Okay. Okay. Win for player one.
Okay. Win for player one.
Oh, right there.
Down in there. Okay. So it looks like there's the advantage. There's our deuce, right? That was actually referred to.
Right.
In the
so
documentation.
If both players have 4 points at any point, I guess it would go to deuce.
Okay. So somehow we made our way down into that if block on 63 to 64. Okay. All right. Now let's try that. So.
Got it.
All right. So this is our player one sweeps the game, right? Player one wins uncontested, something like that.
You guys let me know when you complete this test. I got some
questions.
Good.
I think we got it.
So I got lots of questions from the Twitch chat. The people,
excellent,
the people that are funding this. Nathan, at the price of 0, we had 37 tickets sold today. So I don't know what your product market fit is, but apparently there's a market for you if there's no price. Questions I got from the Twitch chat. Why are we growing tests versus writing individual tests? They noticed
why
that.
Are we growing? Yeah. So we're referring specifically to this kind of sweeps, right?
I think so. I'll give them 1 second because there's a delay. So Jitter Ted says, yep. So yeah, that was a question.
Yeah. So we were just kind of exploring here. What happens if we do these things? So what we might want to do now is looking at this and say, okay, if I score 2 points, I should have 30, right? So we could have tests that call out specifically what 2 points means. And we can start breaking that out of here. Some of what we're doing is just exploring. So if the test doesn't follow whatever paradigm you want, where you do have smaller tests that are focused on 2 points is 30, 3 points is 40, we can definitely break those down and start doing that.
Mm-hmm.
So definitely a good question.
And I'm waiting the second to make sure Jitter Ted agrees. No follow-ons. He says yes, thanks.
Awesome.
He didn't compliment you, just said thank you. Just want to let that know. Now, I'm the middle manager. You get back to work. I'm going to get some hair plugs.
It's a tough crowd.
Hurry up.
Tough crowd.
You only work well under pressure. I read it on a blog post.
Whose blog post?
NathanCarver.com.
Oh, all right. Okay. So we have a test that says wins uncontested. But we do have several steps of behavior, right? As the question pointed out.
Right.
So we have the choice, like we can capture that because we don't really have anything that says 1 point equals 15, right?
Right.
So we could create tests for that
Okay.
call that out specifically. With the way the score, does the object give us any other way to access the score other than just that text?
All I'm seeing
doesn't.
is a score.
Okay, so we don't, oh, it's just a string even. It doesn't keep like a,
Yeah.
oh, there it is, private. So that we have private members up there.
Oh, I see. Yep.
Yeah,
It's
we have some
stored
private
as
members.
okay. Yep.
Okay. So you can start playing like a mental game with yourself. Well, what if I make those members public and then I can examine them, right?
That's true.
Right, we could do that. You know, in this class, there's no risk of, at least I don't see any risk of making a private member public. And it is kind of calling out maybe a potential smell that we need to fix in the future.
Right.
If this was a more, you know, if it was a bigger system, making a private member public could create risk, maybe, maybe not. So that's an option we have. We could actually start examining this object internally. Yeah.
All right.
So we may want to do that, right? We could try that.
You want to try that? Okay. I'll get the getter and setter as public.
Yeah, let's do that. Let's make it an internal setter, right? Let's not let ourselves get too greedy with it yet. Okay, so we're breaking some encapsulation. We're going to use this player wins uncontested as a guide test to kind of examine those point values. Okay. We can start writing tests that do that. So let's do that. Let's write a test that asserts the points.
Okay. All right. So we can probably actually just do that. So, all right, right now we have player one, and they should have 1 point.
Yep, they should have 1 point. So internally, so player one score should equal 1, right?
Right.
That's how the object's going to work.
Game that player one score. Try it.
Yeah, let's try that.
Got some questions coming in, so let me know if serious questions, so I won't interrupt you.
Good. Go ahead. We got a green test, so ask away.
Hey, green test. Wow. What is this? 3? Okay, we'll be done by next year. So Jitter Ted says, what factors would they, I'm assuming they's you, so let me rephrase it. What factors would you use to decide when/how much to expose of internals versus going ahead and writing more tests against game.score?
Yeah, I actually don't, I'm not a big fan of exposing internals. This was just kind of an experimentation. So I don't know if this is going to give us a lot of value, but I did want to explore it a little bit to see if it does give us any value. But I think, I don't know. What do you think, Matt? I'm not seeing a lot coming out of this, but we can definitely move forward with it if we want to.
A lot coming out of making these members public.
Yeah.
I mean, it seems like it's going to be a lot easier for us to, I mean, I just feel more comfortable comparing the ints versus comparing these strings. Like, it just, I don't know. To me, it's a lot easier to make sure that player one score is equal to 1. And then I guess looking ahead, at some point we're going to have a method that converts scores, which are integers, into a string. We're not going to have this kind of like all intertwined together. So I think it does make sense to split it out right now, but I guess that is also kind of anticipating the future, which can be bad at some points because you kind of then you pigeonhole yourself.
Yep. So I think there's, my experience, been two schools of thought. One is, you know, the interface of the object is our point and our score. And that's really when we want to capture the behavior. If we have to expose something, that generally means there's some underlying complexity that we're just struggling with. And looking at this, I don't think that complexity is really there. So we could go on the side of caution and not expose these and say, you know what, there's no reason to expose these yet because we're still, you know, because we're making progress just using the interface of the object.
That makes sense.
Yeah, so, you know, poke around with it if we don't like the way it's going. And the other thing, I mean, exposing can be very helpful if you get stuck, you know, exposing a private, but you're also breaking your own rules a bit. Like, we don't want to change production code until we have a characterization test protecting us. In this case, the risk was pretty low, right? Because there are no other objects that could have a problem, right? So yeah, so now we have a decision to make. Do we like this direction, or do we want to stay with? These are great. Hey Joel, why don't you just invite him in? We'll make this a mob.
We could do that. But I have a quick question from James and Artie. James and Artie, you're saying, why aren't you using a table to do this? And I'm assuming table means data structure.
Yeah, in a test. Yeah, we could definitely do that.
Yep. So Twitch chat.
Good idea.
I since, you know, I don't trust these guys to get the jobs done and we're not paying them. What approach would you like them to take for the next characterization test?
What approach would we like them to take for the next characterization test?
If it's okay with you, I'd ask the audience. What do they want you to do next?
See what the
Unless
public
there's
wants.
more stuff you want to cover, Nathan.
Well, get some answers and we'll keep going forward.
Okay, cool.
So what do you think, Matt? Do we want to keep going with the player, exposing the player score, or just stick with the point?
I mean, it does make sense that these are not going to be, I guess these are not going to be exposed. We're going to keep these. It seems like we would want to keep these internally. So
yeah, I kind of agree.
It does make sense to continue keeping these as private and then exploring this a little bit more.
Yeah. I don't think this test got us a whole lot.
The Twitch chat says, let you guys continue to set your own destiny. But I want you to know, I'm losing the number of hair plugs. I know the number of hair plugs I'm going to be able to afford after this is getting, I don't think you're going to notice the difference.
All right.
All right. So revert.
So yeah, so we'll just undo those and we'll go back to. Okay. All right. So we have a sweep. Let's keep that, right? I mean, that is a condition of the game. Let's keep it, and let's move on. Let's move on to something else next.
Okay.
We could start verifying. So we're making some assumptions in our sweep, right? If I score 1 point, then I'm going to get 15. If I score 2, I got 30. We could go the other way, right? We could say player 2 wins uncontested.
Player 2 sweep. Yeah, that makes sense. We haven't touched this conditional yet. And we've touched this whole, I think we've touched everything inside this conditional here.
Yeah. We could also try some, this would be, we could try some mutations even. Like a mutation would be, what if I go in and I change line 30, right, to not 2, right? Does it break my test?
Okay.
So if we were using a code coverage tool, we would see the lines that are actually being tested start to light up green.
Right.
And we could easily find lines that we actually haven't tested yet. But since we talked about demonstrating some mutation testing, we don't have that. So we might have to start mutating some of those if conditions to see if we actually have it tested or not.
Okay.
So Nathan, you're saying mutation. What do you mean? What is mutation? Is that like Teenage Mutation Turtles?
Pretty much. We'll turn Joel into a turtle by changing just a few. You know, he's already 98% orangutan. We just need to change a few bits in his genetic code, and And there he is. So
And the goal is to make sure my tests fail. Then the tests that we're
yeah,
passing.
so we want to, if we mutate something, so let's do that, Matt. Let's
try
pick
30.
let's pick one of those if statements, and let's change it from an equals to a
Oh,
yeah, let's change it to an equals to a not equal.
okay.
So this is a mutation. So we actually mutated the behavior of the code. Then let's run our tests and let's see what happens.
Okay. Let's run all the tests.
All right.
Nice.
So we actually do capture that condition.
Mm-hmm.
So if that, so we know we've covered that conditional. So now
Right.
we could then go through and mutate some of the others, but we want to make sure we go back.
Not too far away.
Yeah. There's a lot of tools we're not, right? So we're not using source control to where we would just revert this, right? So we don't lose.
Right.
We're also not intentionally not using code coverage tools because we do want to make this a little more challenging.
Right.
So there are some steps we're not using just so we can focus on the tests themselves. But, okay, so let's move on. Do you want to move to the next? Let's move to the player 2.
Okay.
Or I'd like to write some more tests here.
You want to do this one for player 2?
Yeah, we could just do. Do you want to just do player 2 wins uncontested? Because
we could do that
covers
too.
the same thing.
Yeah. All right.
So we kind of we have a pretty good expectation here.
Yeah.
Although so I'm thinking the 15 and the love, right, are going to be inverted.
I believe so. They should be.
Okay, let's do that. We can set that expectation, I think.
Okay.
Or we can make them blank and see it fail one by one, right? That's the other option we have. Yep.
What do you prefer?
Let's make the first one blank. Let's see it fail. And then it gives us a little more confidence. And then we can, just so we know this test is running.
Okay. Yep. And
yep. Okay, as we expected.
You were right there. Yep. All right. Okay. And then just change the rest, you think? Because I think we have a pretty good idea.
We know the
of what's
test is
going on
running.
here.
Yeah.
Yeah.
I'm okay with that.
Okay. That's good.
And we can mutate. Let's do a mutation inside that player 2 block just to see that that's where we're playing.
We can do same mutation as last time.
Okay. Okay. Yep. So that's exactly where we thought we were.
Should run all the tests. Okay.
All right. And we'll revert it back. And
okay.
All right. So I feel like we jumped around in 2 blocks, but there's still a lot of code in there.
Yeah. I think we've hit these 2 blocks. And these 2 conditionals within the block.
Yeah.
But we haven't hit any of this stuff or any of these 4 conditionals.
Okay. All right. So what do we have? Where we can
looks like we have some tie scores here.
Yeah, that must be. So let's try when the game starts, right? It's love. So let's try
love all. So we have that. That's what we're initializing to.
Okay. So let's do a 1-to-1. It looks like maybe 15 alls what it's going to give us.
Sure. Yeah, that makes sense. All right. So we'll say player 1. Let's set this right now. Okay. So keeping in line with our asserts, should we keep this, like keep doing 2 asserts for each time we score a point like that?
So do 2 asserts each time we score a point. No, we don't need to do that because that behavior we captured already.
Okay.
So we don't have to repeat the sweep, right? Score every time we score a point, we check the
That
score.
makes sense.
I think now we can be much more focused on some other conditions that we're looking for.
Okay. So we'll run this.
So what should we get here?
I think we should get 15 all.
Okay, there we go.
All right. Okay. Something like player 1, player 2 tie at 1 point.
Yeah, let's do that. Okay. Okay.
So we
So
hit
then,
this one.
yep. Now we can go to the next if. Let's stay in that.
Okay.
Let's stay in that block, and we'll go to the next. So this at 2 points is our next.
Okay.
So this would be the other approach, and I think that was what the question was pointing at. Is we had 2 tests that kind of do a sweeping block of asserts, and then now we have these tests that are incrementally, right, having 1
Right.
assert each.
And we did we have this one here, which we're asserting 15 love, and then we kind of do a similar thing here, which I don't, maybe that was also what they were referring to, because
Yeah.
these 2 are.
Yep. So we could, yeah, I think there's a couple of things, and we could go through and refactor our test a little bit.
Mhm.
Some of the decisions we can make here are what tests are no longer necessary. What tests, is there a duplicate test? Is there something else that already covers it? And maybe that most likely is going to be, what we find, that a test is no longer needed. It's kind of a stepping stone, right? It's getting us to a much more robust test for a given state. I kind of see each one of these tests is describing a particular state in the game. So the first one is, the new game state. No one has scored any points.
Love
The
all.
second state is player 1 victory. Then we have a player 2 victory. And then we have our tied game states that we're going into.
Right.
Yeah. Yeah, so let's get a green here. Did we get one?
Okay, yep. We do not yet. I think we're gonna have to change this to 30 all.
Okay.
Let me just make sure that's correct. Yep. Looks good.
All right. Yeah, so let's, is there anything we want to refactor in our test before we keep going? So we could we could take our new game and move that to a setup method, right? And just make a game, a global.
That makes sense.
It's a single line. I think it's, right now it's a matter of preference. It does save us some setup. We could remove that one test as well if we decide player scores first point of match. If we decide that the player 1 wins uncontested, if that kind of does the same job, then maybe we don't need that test.
Right, yeah. So I guess in this one, we're just asserting the final result. In this one, where it's asserting the, like, kind of the intermediary. So I don't know if we need to keep those kind of like parallel, or if
I see. Yeah, so should the tie games be written the same way?
Right.
Is that right? So score 2, each one scores, we check the score, they score again, we check the score.
Right.
I think you could make arguments for either way. It's like what behavior are we looking for? What state? What's the end state that we're looking for? And the first two, we were looking for what happens if player one just wins the game, scores all 4 points and wins.
Mm-hmm.
And these we're looking at, okay, what happens if they're tied with 2? What happens? So I guess I'm okay either way.
Okay.
Do you have an opinion? Like a strong opinion one way or the other, I mean?
Not really. I don't have a strong opinion. I think,
Okay.
I mean, I guess if we keep it like this, we can probably safely remove this test because this is covered.
Yeah,
This
I
is
agree.
covered right here. So let's take out that. Okay, let's run the test.
Well, the test is running. One of our astute Twitch viewers noticed that deuce is spelled wrong.
Oh my gosh.
So go ahead, fix it, or you're going to be
No.
looking for a new paycheck tomorrow.
No, we can't fix it.
Why can't you fix it? It's not that hard.
We don't have test safety yet to fix it.
Test safety, test safety, test safety. Give me one good reason why I want you to write characterization test.
One good reason? Because I won't work unless you let me.
Well, that's not a good reason. That's like you read a book about do the right thing. Explain to me logically why you need to do it.
Why do we need to do it? Well, if you notice that deuce is, shows up in a few different areas.
Yeah.
So if we start going in and start changing some of that, we're making some assumptions that they're all part of the same behavior, because they could act independently, right? They're not the same. They're not using a variable. They're not the actual same value, even though the text is the same, right?
But my nephew wrote code, right? He just go in and change it. Why do you need to write characterization tests? Why do I need to spend all this money on writing your code? What do I get out of it as a middle manager? I'm trying to save up for a Ford Taurus.
I'm sorry. I really am, man. All right, where were we? Are we getting anything done here? Manager keeps coming in.
Yeah, right. We just eliminated the 15 love test. This one that was copied.
Okay. All right. Yeah. So let's move on. Let's move to another test here. Okay. So if we want to stay with that state, then we'll need to create a. So we have 30 all. The next one is the deuce, huh?
Deuce. Try that one.
Yeah.
Okay. And we'll do this one. Let's see. Tie it. So that's 3 points. Let's test that. Okay. Looks good.
All right. Now there is some refactoring we could do that cleans up the number of lines we have, like score point, score point, score point. What we could do is if we made game a class level field, we could create a score method that we just tell it, okay, score 3 points, player 1, and that would clean up the code a little bit.
That's a good idea.
It also will abstract away. It'll abstract the interface to the class into a much smaller area. So should that change, then we have fewer touch points within our test that we actually have to change.
Yeah,
so let's do that.
Kind of I've always felt like it's kind of a balancing act between balancing. You want your test to be kind of explicit sometimes, but then you don't want your test to be so explicit that code changes are kind of a burden, I guess. I don't know if that makes sense.
Yeah,
like it feels like when you don't want to make it so that you're kind of it's like a code smell kind of, but I don't know.
Yeah, I agree. You kind of play a game with yourself, and am I adding too much complexity in my test? Right? Do I need to write a test to verify my test is working? And if you have that question, you can look at the production code as the test, like an accounting system. The debits verify credits and the credits verify debits. If you look at your code that way, your production code is going to verify your test, and your tests are going to verify your production code. So if we refactor our tests, but we don't touch our production code, then we're using that existing production code to verify our tests are still working, and vice versa. If we're doing,
yeah, that's interesting. That's a good way to think about it. You kind of, I never really thought about that kind of bi-directional testing.
yeah. In this case, it's kind of lopsided, right? Because we have a lot more
Right.
untested code than, but we do have some. We're starting to generate some safety here because we do have 6 tests now.
Right.
So I think we're getting to a point where we could start refactoring the test a little bit more and safely do so.
I have a real question from Twitch. No, is this a good interruption point, or you can tell me to go away?
Mm-hmm.
So, question
I'll tell you to go away after.
Jitter Ted says, he says, when, and I'm assuming it's a him. When are you done writing characterization tests? When do you know you have them all written?
Yep. Good question. So normally what we would do is when I'm doing characterization tests, I will use a code coverage tool. So the tool is going to read out to me how many lines of code have been covered by my test suite. Ideally, I want to get to 100%, not just 100% line coverage, but 100% conditional coverage as well. So we have every if block, every if condition covered with tests. Because we do not have code coverage running, we're making it a little bit more challenging on ourselves, where we're going to have to get to a point where we think we've covered it all, and then start making some mutation changes to see if our tests break. So I think if we do a second phase of this, Joel, I think using the code coverage tool will be a really great comparison for people to see how much easier it makes it.
Great. I think that's the only question I saw in Slack. I mean, in Twitch. Sorry, Twitch. I didn't want to insult you. But we're coming up to the hour point, right? I'm pretty sure we could go all night on this. But I want to set expectations to those people at Twitch that are probably wondering, should I go to the bathroom now or should I wait 15 minutes? How long do you think, Nathan, do you want to go? How much more do you want to cover? And we're always open to Nathan Carver showing up again and doing characterization test part 2.
Part 2. You know what? Let's do that refactoring in the test that we talked about. And we can wrap up with that. But let's use our production code, right, to verify that this change we make in the test
and before you do that, Jitter Ted, he's quick on the keyboard, says, and I think this is a question. So 100% code branch coverage for only the class you're covering, or your whole project?
For all the behavior that you need to cover. So we're looking at behavior. We're testing the behavior of the system. In this instance, there's only a single class. And it's very easy to see, like we're testing a class, but really what we're trying to do is test behavior of the system. And so let's say we have a larger project with, half a dozen classes in there. Well, let's say there's a more elaborate tennis game and there's, 6 or 7 classes under the hood, but there's still only the 2 interface points of point and score, right? So we want to still test at the entry point of the system. Mm-hmm. And we want to generate enough test coverage that we start creating safety to make changes. And so as you get into legacy refactoring, mm-hmm. if there are parts of the system that never change and you're never going to touch, the need to spend a lot of time creating characterization tests there, it may not, it's going to have diminishing returns because you're going to spend a lot of time testing, but you'll never touch the code. So what you really want to do is create code coverage and test safety around the code that you intend to change, the code that perhaps is brittle and causes mm-hmm. a lot of problems. That's where you want to focus your efforts in a larger system. And cool. You don't have to do it at a class level. You can do it at the behavior of the system. So the entry point of the system.
Roberto says, I have a question. Is code coverage 100% reliable for characterization test? He doesn't think so, but he's wondering what else you would use other than code coverage. You said something like mutation testing beforehand. Would that help?
Yeah, so is the code coverage tool giving you 100% confidence that you can go make a change? I wouldn't say 100%, but I would say I'm very confident if my code coverage tool says that it's covered. I have a lot more confidence going in and making a change. Could there be something? Absolutely, right? There could be some type of configuration property that your code coverage just can't capture, right? Unless it has a very specific condition.
Would
So
I?
there's absolutely some risk, but we're looking to minimize our risk as much as possible. Does
So
that
as long
answer the
as,
question?
yeah, I think the part, and I know you personally, Nation. So I want to add the part I think you're missing that you would say automatically is you would look at the test, because you can write one test that would have 100% code coverage. So you want to make sure the tests are actually quality tests.
Yeah, so we could write a dozen tests that cover the entire system, but we don't assert anything.
Right. So
We could assert not null on every. So if we write a dozen tests and we assert not null on every game.score call, none of our tests are going to fail. We could have 100%. We could be hitting all the lines of code, but we really have no idea what behavior the tests are capturing. So I think, is that where you're taking it, Joel?
Yep. I would, so is your recommendation to actually examine the test to make sure they're good tests?
Yeah, definitely. And that's what we're trying to do here is do these tests. What behavior are they covering? And we're using our asserts, right? What's the intent of this test and what's it asserting? So far, our asserts have been very deliberate in the outcome that we're expecting, or the outcome that we're exploring. And so that's very important that your asserts are, you don't want to just assert not null, for example,
So
unless there's some behavior reason to do it.
So is your recommendation, well, I got 100% code coverage. Let me go look at these tests. And let me make sure that they look like good tests and do a little mutation testing before you start changing the code that you just inherited.
Mm-hmm.
So that would be your.
So say the question again.
So would you, if I was going to recap what you just said was, I'm inheriting code that has 100% test code coverage. It has a bunch of characterization tests or tests of some sort. I'm going to look at the test, and then I'm going to do this thing called mutation testing to make sure the test actually, I'm going to change a greater than to a less than just to see if a test breaks. And if it does, I'll change that code back, and then I feel confident I can change some code.
That's right. So if you inherit some tests, we didn't inherit any tests here. So our tactic for mutation testing is, did we actually cover this block that we thought we covered? And if we make a change, we should see it fail. If you inherit tests already and you don't have a high level of confidence in them, mutation testing is one way to do that, is make a change, see if that test fails. Because if it doesn't fail, then it's probably not helping you a whole lot. The first thing I look at when I get existing tests is, what are they asserting? Are they asserting the behavior the name of the test is actually saying it's doing? And is it the same type of asserts in 100 different tests? So those are some of the things I look for. And you can certainly use the mutation testing to challenge all those tests. And that goes back to the test verify production code, and production code can verify tests. If you're only making changes in production code to see if your test suite is actually doing its job, that's perfectly fine, because you're going to try to verify the tests.
Cool. And one quick question before the manager goes away. And when
Finally.
you guys close it out, just invite everybody to Lean Coffee, and you can fire the manager right now.
Awesome.
Roberto's asking is, what if we wrote the test before we wrote the code? Would that help? And I don't think you need a long answer on that one.
Yeah. I think that's a leading. Yeah. I see what he's doing there. Yes. Yes, it would.
By the way, continue doing what you're doing, and join us for Lean Coffee afterwards on Twitch.
Awesome. All right, let's do this.
Stop interrupting now.
Are you sure?
Let's refactor.
I made a commitment. Matt will produce.
All right. Whew. Glad that guy's gone. Okay. Yeah. So let's make let's just put game as a member of the class here, as a field.
Okay. Guess we can do a read only.
Yeah, we may actually move it to the setup. Would that work with read only, or will C#
In the constructor.
Ah, okay.
Uh,
Let's try that.
just to do testing. Or I guess this is the normal C#, right?
Yeah, I think so. Microsoft's attempt to be different.
And pass test player 1. Okay. Does that look right so far?
I think so. Yeah, so let's change just that first test and run it before we go
Okay.
too far with it.
So
So that already exists. So now we can just
should be able to do this dot tennis game dot score.
compiling. Looks good. Let's run it.
Looks good. All right, let's run. Let's test here. Yep.
Okay, so it was happy with our constructor approach. Good.
Yeah.
All right, so we know that works. Let's change, before we do our entire suite like this, let's change love all. We'll challenge the test a little more. Let's just say
Okay.
fail. So just, yeah, mock up the text. There you go.
Something like that.
Okay.
Okay.
All right, we got control of this.
Sounds good.
All right, so now we can move this refactoring to the other methods.
Okay. All right.
So what I would, before we drop the line 29, let's rename game to underscore tennis game on line 29.
Okay.
Visual Studio will do some of the work for us. So I think you can, was it Shift F6 or right click and rename? One of those will.
Oh, I see. Yep, got it.
Control RR, that's what it is.
Yep.
Just underscore tennis game.
Oh, that'll do it. That'll do it for us.
Yeah, since it's yep. And now when you drop it, it'll be fine.
Okay.
This is accurate as well, but because we don't have a parameter, there's no confusion with whether we're accessing field or an internal property of the method.
Right. Okay, that makes sense.
So yeah, now we can delete line 29.
29.
And we can run that.
Should be good.
All right.
All right. And same for this one?
Yep.
Kind of a habit. I normally just run one test, but I should be really running them all. Oh.
Yeah. Oh, what do we get?
15.
All right, let's undo that before we get too far. Okay. All right, so we renamed. Let's run it again. Let's make sure that we're still.
Yeah. Okay, we're good.
Okay, we're back to green. Good. Okay, so we renamed. Yeah, let's try it again. Let's just do a rename on it and run it before we drop the initialization. Okay, now let's run the test here and see what happens. Okay, still green. So comment out that 44 and run it again. This should pick up the field. Oh, look at that. Okay, so unexpected here.
Oh, expected low 15.
Let's go look at our constructor. Up in the, scroll to the right. Interesting. Okay, unexpected here, behavior. That's really puzzling.
Yeah.
Could it
I'm
be?
wondering how this.
Which one's it failing on?
The first one here, this 48.
Oh, look at that. It's saying player one win. So it's already in a win state.
Right.
Okay. I think what we may have discovered is the constructor is only called once. And it's maintaining, yep, it's maintaining the fields across all the tests. So, all right. So before we change
it worked with these first two. Okay.
Yeah, before we change that, let's put this breaking test back to green, and then we'll go refactor our. We're going to be punished, right, for not using source control on this.
Yeah, right. Okay.
Okay.
That's good.
So let's scroll up to the top here, and so let's move this into a setup.
Okay.
So we'll create a setup method, and I believe the annotation for NUnit, I think this is NUnit, is just setup. And I think it's uppercase U. Yeah, I got it.
Like that. Setup test.
Yeah, let's do that.
And then, so is this run before each test? Okay.
Yeah, this should be run before each test.
Okay.
And we'll move this guy in there. Then we'll probably have to remove the read only because it isn't going to like that.
No. All right. All right, let's run the test.
Okay, we're still green. So let's move down. Now let's make this change.
Okay.
And see what happens. Okay, good.
Nice. Okay.
Now we're green. So now we can move forward here.
Okay. All right. I'll take out these lines.
Yeah. Looks like we went a little test crazy before we refactored, huh? We got a lot of touch points.
Yeah.
This is good, right? I think this is what we were talking about, is your test becomes difficult to maintain because if you make any changes, there's a lot of areas you have to touch.
Right.
If we have 6 tests and it's taking us a while. If we had 100 tests, we'd probably say it's not worth it.
Not worth it.
Right? Yeah.
All right.
Okay, so let's try to. The last thing we'll do here is let's abstract away some of that. We've abstracted away the creation and the starting of the game. So let's create a method that is called score.
Okay.
So inside, let's try to do this. We'll try to do an extract method technique on this. So let's go down to the bottom test where we're calling point 3 times in a row.
Okay.
So rather than doing that, let's just create a for loop. So essentially we're going to call a method and we're going to give it a player, right? And we're going to give it the points that we want. And it'll just look through and score that many points for the player.
That makes sense. So just do the for loop.
Yeah, we could do it right in line and we could extract it, or you can just write the method either way. So we could say, let's just say so for
equals 0, less than 3.
Yeah, so let's do that. Let's do one at a time.
Okay.
Yeah, we'll do one player at a time. And then we can call the same method again if we want.
Okay.
So if you do, so I equals, so var I equals 0, and then shift your semicolons over 1. That's all it is.
Okay.
Yeah, so just delete that semicolon and the I. There we go. Yep. And then there's I++.
Yep. Forgot how to write a for loop for a second.
That's all right. It's the manager. They just create a lot of stress.
So we'll just delete this.
Delete that. Let's run this. We'll make sure that that's doing what we think it's doing. Again, using our production code to verify our test change.
Right. Okay, that looks good.
Okay. Okay. So let's get rid of the duplicate code. So if you take the 3 and turn it into a variable.
Okay.
So let's call it var points equals 3. There we go. And then I points. No, I'm sorry. I apologize. I said that wrong. Yeah, I
no,
less
okay.
than point.
Yeah. I was thinking we could do a minus minus, I guess.
Yeah, I totally threw you off. Okay, so good. So now we could, before we extract a method, we could pull player 1 out to a var. I think my Visual Studio foo is not strong enough to do the keyboard completely in this, but if you just select 83 through 87, we can extract that method.
Okay.
Yeah, we'll have to add a variable, but that's okay.
Is it in a refactoring?
Yeah, I believe so. It should be, there we go, extract method.
Okay.
So let's call it score points for player. And it took, my mistake. I told you to include the var, but that's okay. So let's.
Oh, that's okay.
Yep. So now what we want to do is points will just become a parameter. So just have an int points up there. Yep. And then we'll have a string player.
All right. Yep. I'll just update these real fast. That's
and
good.
it can just be a void. It doesn't have to
void,
return.
Yeah.
So. I messed up that smooth refactoring. It could have gone so much better.
Worked out.
That's okay.
Yeah, I didn't know about that trick. That's good.
Yeah, if you're good with the refactoring on the keyboard in Visual Studio, you can do a lot of that without having to.
Oh yeah, saves a lot of time.
Typing up, yeah, for sure. All right, so let's get rid of that int points equals. We'll just call score points for player.
Okay.
And then we'll give it our points that we want them to score, which would be 3. And then we'll say the player. Yeah, and then we'll do 2.
Oh, well,
player 2.
Should we, yeah, we could.
Oh yeah, then we can just delete what's after that.
Okay.
All right, let's make sure this is running like we think it is.
All right, looks good.
Okay. So then what we could do is, now if we go through and we update all these, right, it's going to shorten the test a bit. And, shorter tests are easier to read.
Definitely. Yeah, this will be a lot clearer. And
then what it also does is abstracts away the interface to the class to a single entry point.
Right.
Right. So
and even though we do just one point here, because of that abstraction, it probably makes sense to replace it.
Right. Now this, and then we could do the same for score. We could even create a method that asserts score for us, and we just tell it what to assert. So then we would abstract. You see, every task is still touching the score method. So if we had some type of assert method that accessed the score, then none of the tests would then be touching any part of the actual object's interface.
That makes sense. So let's
so
that out.
Yeah, let's just do that, and we'll just do it on these 2 tests and call it good.
So we'll do return a string here.
You don't actually return anything. So what we'll do is, let's try this. So right after line 84, go ahead and delete that line. And then what we'll do after line 84 is we'll just create a method called assert score.
Okay.
How about we'll call it assert score equals, and we'll pass in deuce to that method.
Okay.
So it'll be a new method. You can just put it in line on line 85, and then we'll have Visual Studio create it for us.
Okay.
Yep. So just assert score.
Score
Assert score equals,
equal.
and then we'll pass in the deuce.
UECE.
We'll spell it wrong. Yep. And then we'll have Visual Studio. And then what we'll do is cut that line 84 and put it in to that method.
Okay.
And then replace the deuce with our string. So that would just be maybe score.
Score.
Expected score, perhaps.
Expected score. Yeah.
Yeah. Do that.
All right.
So why do this? Right. So it abstracts away the access to the tennis game. Right. So now our test
so at
is
this
not
point,
touching.
we're only calling tennis game here instead of anywhere else.
That's the advantage here. Another advantage to doing these kinds of methods is this would be the approval test, right? What if we had 6 or 8 properties we wanted to verify for a given state? Something like this could help do that, where you may pass in an object, like a comparator object of something, but.
Right. Oh, did I? I don't think I ran the test.
Oh yeah, let's run that before.
Well, I have a question, but I don't want to interrupt your flow. Let me know.
We're good. What's your question?
Yep.
Roberto asks, when do you know the refactoring method belongs to the test instead of the class?
When the refactoring method belongs to the test instead of the class?
Yes.
The refactoring method. I'm not sure I completely understand. So, is this in relation to the methods we just created that we refactored out?
This is probably
of the
about
test?
5 minutes back. Yep.
Okay. 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 Yes. Good question. So these refactorings, they belong to this test because they're doing something specific, right? For this test to test the behavior of the system. If we had multiple tests, we might come in and say, okay, they both need these kind of methods. Should they all be in one test? Should there be some type of assert fixture or some type of assert class that does work for us? But in this case, these definitely belong in the test. I don't know if I think I'm answering that correct the way I hear it. What do you think, Joel?
I think you did. Roberto, if you need clarity, just pop it in the Twitch chat. You can always answer it in Link Coffee.
Yeah, thank you, Roberto. Appreciate the questions.
Yeah. And that's the only question I have. The other statement I have to make is click the follow button on Twitch. I'm not sure why we need it anymore, but do it. I'd like to be able to keep track of, we'd like to be able to keep track that you were a follower of us. Nathan, you don't have to do it unless you want to.
All right.
Sorry to
I'm not going to help my manager get hair plugs.
That's on my PowerPoint. Okay. We have to do it. It's a win-win.
In your LinkedIn.
Yeah, we're going to need you to come in on Saturday. And while you're at it, come in on Sunday too.
All right. We'll do that.
I'll be at Schlosske's.
All right.
All right, I'm going to throw this one in here too.
Yeah.
And
start making progress. You just don't want to stop, right?
Yeah. Oop. Okay. There we go.
Yeah. We could even make those, and we don't have to do this, but one option is to make the score points for player even more deliberate, right? So we could have 2 separate methods that.
That's true.
Score points for player one, right? And pass that in.
So
there could be advantages to doing it.
Something like score points for player one.
Right.
And points. And then would you just do like something like this, that score points for
yeah, you could do
player
that. Yep.
Points.
Kind of overloading that method.
Something like that.
So the reason I would do that is if I felt like, I don't want my tests having awareness of player one, player two variables, right? The test is only aware that there's a player one and there's a player two. It doesn't really have understanding of how that reference is created. So it does remove that dependency, right, on that variable from the other
Right.
test.
That makes sense. Because we may not use that based on how we refactor. I don't know.
Right, exactly. And more complex system, that could save us a lot of touch points
Right.
in future refactorings. Here, I think it's, preference, but
yeah,
a tactic. All right. Well, thank you, Matt.
All right. Yeah, of
good.
course.
I enjoyed
Yeah,
that.
that was a good time. Yeah.
We even enjoyed Joel jumping in.
Yeah.
I'm just playing a role tonight of
It
the
was
manager.
helpful.
It was on the script. The producer gave it to me. I'm just an actor in this the theatrical engagement.
Right.
Nathan, Matt, thank you guys so much for doing from this. I'm going to give the Twitch chat a chance to give some feedback. I love to get live feedback on this. If you guys would like Nathan and Matt to do round 2 characterization tests, maybe sometime later this summer or fall, drop it in the Twitch chat. Next July 15th, right? So that's 2 weeks from now. Brian's going to be doing Matt, can you say it?
Contract-driven development. Oh, I had slipped up there too.
Yeah. Contract-driven development, same format, right? So make sure you mark your calendars. Go to events.cantoncoders.org to get an RSVP solely for the reminder to show up. After this, we're going to do Lean Coffee. I'll drop the link into the Slack chat. And tomorrow, we're going to do Lean Coffee also. So tonight, let's keep the Lean Coffee focused around testing. Is that fair, guys? Like no org management, none of that fun stuff, not the stuff we argue with to our blue in our face, right? Let's keep it nerdy on code and focused on characterization tests. And if you want to argue t-shirts versus points, tomorrow night's the night for you. But anything else you guys want to add in closing?
No, thanks for letting us do this. It was fun.
Yeah.
Thank you, Matt.
This was a lot of fun.
Enjoyed pairing with you.
Yeah, I had a lot of fun.
And I think this is a record. So this is the first time that 2 people from Michigan actually did one of these. Like, it's reasonable that both of these people will show up in person. So if you're not in Slack, Matt, can you drop the link in Slack?
Yep.
And I'm going to leave
this call.
Yep. And I'm going to leave this broadcast up just a second. I'm going to cut the Zoom link, and we're just going to go back to that beautiful, beautiful welcoming scene where that guy named Joel stands in front of the library and welcomes us all to Canton Coders. Thank you for tuning in tonight. Hey everybody, welcome to Canton Coders. I'm Joel. Behind me, we have the Canton Public Library where we plan to meet once the library opens up for group service hours. Tonight, we have Nathan Carver. Nathan Carver is a friend of mine, and he'll be talking about characterization tests. But before we talk about characterization tests, I just want to call out to the upcoming events this month. Every Thursday night in July, we'll be having a Lean Coffee. So what a Lean Coffee is we get together and we discuss the topics that you bring in an orderly format. We've had about 14 people attend every night, and coffee is optional. During the Lean Coffee, we identified 2 new formats for content that we want to try. So the first format is Karen is going to host a Lean Coffee for junior developers. This is more about recursion, object-oriented programming, functional programming, when to use a do versus a while loop or do while loop, those type of questions. Seniors, I know you want to come, and that's awesome. We ask if you do attend, you listen and let Karen answer the questions, because Karen and her guests will be using Socratic methods. The next event is July 15th, when Brian Finster will be doing his workshop on contracted development live on Twitch stream. Check that out at events.cantoncoders.org. And finally, we have one more big event this month, and this is going to be more a release to YouTube, is we're going to try to do what we call a code interview, or it's a podcast, a vlog, I don't know what it is. This is something where James was thinking it would be cool if we did less than 15 minutes with someone that was interesting about something around code. And our first guinea pig is Guy Royce. He's a developer evangelist, and everyone wonders, what does that job do, and should I do it? Would I want to do that? But tonight is Nathan Carver. Nathan Carver has been a friend of mine for several years. He's a professional software engineer. He writes the cleanest code I've ever seen, so clean that you can probably eat from it. And Nathan, I think that means I've introduced you and we're ready to go. Thank you.